Enterprises, and I'd like to thank you for joining us today for this month's Best Practices webinar. And I'm really pleased to have on the line today a new guest speaker to us, Bill Barto, who's the Director of Reliability Solutions with Lifecycle Engineering. But Bill is certainly not new to the industry, and he holds a degree in mechanical engineering from the University of Central Florida, where he's been a lifelong resident, and he has a master's in reliability and maintainability engineering from the University of Tennessee. He's also a CMRP, an ASQ certified reliability engineer as well. And prior to joining Lifecycle Engineering, where he's held a variety of positions, he's also he came to us from the theme park world, most recently from Walt Disney World, and where he led several different reliability efforts. And in that role, so we're really pleased to have Bill join us today. And Bill, we've had kind of record attendance, or at least record registrants today, so I think this topic of how do you transition out of run to failure must be something on a lot of people's minds. So can you tell us a little bit, Bill, about, you know, in your vast experience, why you selected this topic and why you focus on it, why it's important?
Sure. No, well, first off, thanks for having me this afternoon or this morning, I guess, and I'm happy to be able to participate in this as well. Running to failure, or especially transitioning from, and I'll probably start using the word, you know, a reactive culture to a proactive culture anyway, is probably a big topic for a lot of people, mainly because of the benefits and the value that's achieved from moving from this reactive culture to a proactive culture. We tend to maybe start off, and historically, certainly when machines were much bigger and more mechanical in nature, without a lot of the electromechanics that are involved today, run to failure was a perfectly acceptable mode of running your maintenance and operations. And as time has come, and more industries have found themselves under pressure to make sure that the availability is maxed out as high as it can be, there's been less and less of a tolerance for having the minor stoppages, the long downtimes, and it's become more and more important that the equipment be used for its full life cycle as long as possible. Certainly equipment's become more and more expensive and more complex. So all these things, I think, combined together have come to show that really being proactive with your equipment and making sure it lasts as long as possible is about the only way that we can be able to survive out in that competitive market, certainly.
Makes good sense, Bill. All right, well, listen, before I turn things over to Bill, let me just go over a couple of quick housekeeping items. For all of the listeners out there today, we are recording this session, so I have your phones on mute, but Bill has agreed to stay through the hour and answer any questions you might have. So please go ahead and type whatever questions you have into the questions feature in GoToWebinar, and I'll ask as many of them as Bill as possible. We're also going to be doing some polls, and we're going to want your responses on those throughout the session. And lastly, Bill has also agreed to share copies of his presentation with whoever is interested, and there'll be a brief survey at the end of the session where you can check a little box if you'd like to receive a copy. Okay, so I think that's it for housekeeping, and Bill, I'm going to turn things over to you.
Great, sounds fine. Thank you. Well, welcome everybody. Like I mentioned earlier, I'm happy to be here today to talk about this topic of transitioning from a run to failure culture, or like I mentioned earlier, I'll probably start referring to this as a reactive versus a proactive culture. So let me go through real quick, and we'll look at the agenda. So the first thing, if you remember, maybe from the bullets that we shared with you earlier, we'll start off with looking at really the trade-offs between a reactive and a proactive maintenance culture. And Really, when I'm talking about reactive, we're meaning where you're waiting for the failures to happen. There's no anticipation. Proactive, in this case, I'm talking about anticipating the failures, reacting accordingly. So we're encompassing a predictive and a preventive maintenance into this term proactive as well. So the first thing we'll do is we'll look at maybe what you get from this transition from a reactive to a proactive culture. The next topic we'll look at is the value of proactive maintenance. I have a quick example of how we can monetize and show that true value in a quantitative sense. We all probably realize that proactive maintenance is the right thing to do, but being able to put that into dollars and cents is really important, and be able to show how going from a reactive maintenance culture where you're not investing the money, we'll term this as a true investment in proactive maintenance, and I'll show you an example of how that actually pays off over time. And the last bullet we'll look at is I've got 3 basic steps on how to get from a reactive culture to a proactive culture, and I'll spend a little bit of time in each one of those steps showing you how we believe the process is from going from purely reactive to a more proactive culture. And so I'll spend a little bit more time in each one of those steps as we go through. But first off, I'd like to just get a take from the audience anyway about how you would currently rate your maintenance culture. The best I see would be a mostly proactive culture. Is anyone out there fully proactive? I doubt it. Maybe you are. If you are, just go ahead and leave it in that mostly proactive. You do some proactive. Maybe you're able to anticipate some of your failures on a particular piece of equipment, so that would be a some proactive. If you're mostly reactive or completely reactive, would be those other categories as well. So if you wouldn't mind, try to see which one of those you fit best into, and give me an idea, and I'll turn it back over to Rona so she can pull the poll up.
Great. Okay, so I've just opened up the poll. So if you don't mind giving us your response, these will be kept anonymous, but we're just trying to get a feel for overall of all our listeners out there today, which category you fall into. Are you mostly proactive, some proactive, mostly reactive, or at the moment completely reactive? All right, looks like we've had about 3/4 of the votes in, so I'll leave it open a few more seconds. And again, just respond to the poll. You don't type it in the questions features, but in the poll features. Okay, 90% in. Okay, let's close this and share the results. So, Bill, what our listeners have told us, 9% are in the mostly proactive, 39% do some proactive. The majority, 45%, or I should say the largest number of respondents, were mostly reactive, and 6% are in completely reactive mode. All right, I'll go back to you, Bill.
Very good. Thank you very much. Yeah, the concepts, and specifically the 3 steps that I'm going to talk about in this, could certainly apply to any of these groups. They're ways of getting your proactive maintenance culture off the ground, but the same concepts can be used very easily to be able to take some of those that are in that some proactive or even the mostly proactive, and perhaps to fine-tune. Being proactive and isn't necessarily, there's a good time to be proactive, and being ultra proactive may not even be the best scenario for your situation anyway. There may be cases where, and we'll talk about this as well, that some equipment, due to its criticality, the right answer might be to let it run to failure. So the opportunities are here with this process that I'll describe on being able to fine-tune any of those programs, be it from both ends of the spectrum. So the next thing I wanted to show real quick was an interesting study that was done through the University of Tennessee's Reliability and Maintainability Center by Dr. Carl Klaus Block. He did 2 samples and 2 surveys of over 200 companies, once in 1991 and again in 2008. When he surveyed these companies back in 1991, he found that over 55% of the companies that he surveyed deemed themselves to be reactive. And when he did that survey again 17 years later in 2008, he found just over a third, so down to about that 33%, now called themselves reactive. So there was certainly a shift during that time of more and more companies adopting a proactive way of thinking and moving away from that reactive culture. And another piece of data that he captured while they did that survey as well was what I'm showing there on the y-axis, and that's the amount of money that these companies spent on their maintenance, normalized over what the original asset investment was. And he found a significant savings. These companies were spending less on their maintenance expenditures as a result of becoming less and less reactive or more and more proactive. So this is an interesting indication of the sort of the scale of those savings that you should expect, and part of the reasons why. And this is one of those trade-offs. As we move to a proactive culture, we begin to see savings, and those savings come out in the amount of the money that we're going to spend on our maintenance as well. So I thought that was an interesting piece of data that was gathered. I expect him to do it again too, and I'll be very interested to see how this begins to change as we move maybe even more and more of these companies, the bigger percentage, become more proactive. So let's talk a little bit about the value, the actual quantitative value that you get from proactive maintenance. So I mentioned that I was going to go through a quick example of 2 scenarios. So I've got a scenario here where we're looking at a purely reactive maintenance culture and one that's a proactive maintenance culture. So the way I'll describe this, and it's very basic, there's a lot more that we could do with this, but I'll just quickly, just for talking purposes anyway, we'll talk about the culture. And the scenario 1 has no annual cost. I'm not spending anything on maintenance every year, so I've got a 0 there. Let's say this particular piece of equipment that I'm talking about, we'll for this scenario anyway, we'll say there's one particular piece of equipment or an asset or a component that I can expect, because I'm not doing anything proactively to it, might last about 3 years before I have to do some sort of repair to it. So I just threw a number, $1,200 every 3 years or so. I've got to do a small repair. And I can expect about 6 years of life out of this piece of equipment as it is today. And in 6 years, I'm going to have to replace it and spend about $30,000 on replacing it. Now look at this as a contrast. I look at a proactive maintenance scenario here, and let's say I've decided here that I'm going to spend $500 every year maintaining this, and maybe this is just basic servicing or basic lubrication. And what do I get for that? Well, I still may have to repair it, maybe every 4 years now. So I get, I get to put off a year before I have to really put that repair cost into place. Maybe it's not quite as much because I've been spending some money every year. But let's say I get to extend its life about 4 more years. And that's really where we're talking here, is one of the major benefits of moving to this proactive maintenance culture is being able to extend equipment life. So I spend a couple $100 a year, and I get to move this thing out another 4 years, but I'm still going to have to replace it someday down the road for that same $30,000. So there's my two scenarios. One way you could look at this is just, well, so how much money am I going to spend over the next 10 years on this? So if I'm reactive, I'm not going to spend everything every year, so there's my 0 times 10. Every 3 years, so 3 times, right? So in 3 years, 3, 6, and 9, so 3 times I've got to spend that $1,200, and at the end of the 10 years, I'm going to spend that $30,000. So I might say, well, look, I'm going to spend $33,600 in the next 10 years. And in the proactive case, I'm going to spend 10 times, 10 years, I'm going to spend that $500 twice. In years 4 and 8, I'll have to invest that $1,000. And then at the end of the year, so I'm still going to spend the $30,000. So in this case, it would appear as if being proactive might actually cost more money. I have to spend more money. In the 10 years, I'm going to spend $37,000 compared to the $33,600. And what I want to show you now is a real financial way, and we're not going to go real deep into the economics. This isn't an economics class, but I do want to introduce to you the concept of present value and net present value in particular. So money doesn't have, especially future money, doesn't have the same value in the future as it does today. So like I said, I'm not going to bore you with all the specifics of the financial part of this, but there's a concept called present value. Present value, here's the formula. N would be the number of years in this case. So if I was looking at the present value of my cost in year 10, I would substitute that $30,000 cost, and I put in an interest rate that sounds reasonable, and then I would substitute 10 in for N. So I can do this for each year, and I'm not going to show it here. If you're interested, let me know, and I can share with you all the details by all means. But if you start thinking about this, and the concept is, if I can spend money further out into the future and spend that $30,000 instead of year 6, but out in year 10, the impact of it today on the value of my money is much decreased. It's much smaller than it is the 10-year spending versus the 6-year spending. So I can do more with that money today, so that's where that real concept comes from. So net present value is then the sum of all those year 1 present value, year 2 present value, year 3 present value. So I'll jump to the end here where I show you the end result of the net present value over 10 years, and I went with a 10% interest rate. So if I'm spending reactively, I'm spending all this money in this reactive sense, same scenario, the net present value, the sum of all those present values of the next 10 years, come up to be about a little over $19,000. But the interesting point is that if I spend, and I do the same calculations, but with the proactive sense, the actual cost comes out to be less. And this is where we demonstrate the fact that extending equipment life, moving things out in time, being able to, even though I'm summing up the money, it sounds like it's more money in a proactive case. That when I think about it in a net present value, what's all that money worth to me today, it actually comes out to be less. And this is the point we need to make as we're out there trying to show the value and convince others of the benefits of going with a more proactive maintenance. These are the type of calculations. This is the language we need to be speaking with our managers, with our plant managers, with those individuals who are going to be making a decision on whether we're going to proceed with some of the steps I'll talk about in the future. So like I said, if you want to get more information, you want to get more down in the details with this, I'd be happy to share that with you later on. I just quickly graphed this. I thought it was an interesting thing to see anyway. So the red value down there, the 33,600 is that reactive case. So you can see that big jump in year 6 where we had to buy the new equipment. So you can see the proactive case actually spent more money. You can see what happens if I also plot the net present value as well. You can see how the two values, the green flip-flops over the red in this case as well. So it's just a nice little graphical way of being able to show that as well. I thought that might be interesting. So with that, I want to talk about how and some of these steps that we can use now to get from a reactive to a proactive culture. So the first, I broke this into 3 steps. Hopefully they're easy to remember. I gave it the idea of where, how, and what. And so when we talk about where, what we're really talking about is classifying. Where do we go? Where are Where are our components? Where are our assets? Where are they in the plant? How do they relate to the other assets within our plant? And I think it's very important to be able to get a good understanding of where our equipment is and how it relates to each other. The how step is really my my analyze phase. So now that I understand where the equipment is, how do I analyze it? And we'll talk about criticality in this step, and I'll talk a little bit about risk control. Typically we use failure modes and effects analysis, so I'll go into a little bit of detail on that as well. And then the what is really my control and analyze phase. So after I decide where my risk comes from in that how phase, I need to put things into action. So I need to get, so what am I going to do? What am I going to do to help mitigate those risks? What am I going to do to monitor? And we'll talk a little bit about some metrics really fast. What are those metrics I need to do to verify that I had the results that I plan to have? So I've got another quick poll if I can. So I'm just kind of curious how many of you have an equipment hierarchy. And when I say hierarchy, I mean in your CMMS, in your EAM, do you have that parent-child relationship spelled out between your equipment? So what equipment belongs to what area, or what area belongs to what functional location? So I guess you would either not have one, yeah, you might have one, but you don't trust it, you may not feel it's very accurate, or yes, you have one and you're very confident in its accuracy. So I'll turn it back over to Rona to put the poll up.
Okay, well, here we go. We're asking your feedback on the current state of your equipment hierarchy. So just let her know either that you don't have a hierarchy, you have one, not to be trusted, or yes, you do. All right, because I'm sure Bill will be covering soon why that's important. Okay, we have about 80% of the votes in, so I'll leave this open a few more seconds. Okay, great. Okay, thanks for your feedback, and let me share this. So Bill, 26% said no, they don't currently have an equipment hierarchy. 28% said yes, but it's not accurate. So just over half either don't have one or have one they don't have a high degree of confidence in. And then 45% said yes, they do have a hierarchy. All
Very
right,
good.
so back to you.
Thank you very much. Well, that's great. That's good to see that, that there's a significant number of people that do have a good equipment hierarchy that they do trust and have some faith in. I think it's a really important notion, especially as we progress through these steps, and we'll see in a minute why knowing what equipment lives in a particular level of your hierarchy will help us when we get into the criticality stage. So I just want to share for those who either don't have one or don't have one they particularly trust, I'll go into a little bit of what I believe a good hierarchy would look like. And I'm borrowing this ISO standard you see down in the bottom left-hand corner, ISO 14224. The 2006 edition added a 9th level to this. Prior to that, there were only 8 levels in this. But the way that they break it down is the top of the pyramid, and the reason it's a pyramid is you're going to have far less items, things at the number 1 level, the top level, than you will down at the bottom at the 9 level. And so the way that ISO 14224 breaks this out is the top of the pyramid is this use location section, and the examples or the category names that they give it are, you start off with your industry, and then there's maybe a number of business categories that belong to that industry, and then installation and the plant or the unit, and there may be a number of plants and units that belong to this single or one of the installations, and sections and systems. And so those 5 levels constitute that use location area, and then below that we really start breaking it down into the equipment subdivision. And so the category names we have down there is now we're breaking it down into equipment units, subunits, components, and parts. Now, I'm not saying that the only good hierarchies have all these categories. I've worked with plenty of clients who do just fine with 5 to 6, 7 of these. The important part is that you don't have a flat hierarchy. You want to make sure that there's a gradual expansion as you travel down the pyramid, as you dig deeper down into your hierarchy. We see many that have maybe 1 or 2 items all the way down to you get to level 5, and then it blows up, and they have thousands and thousands of pieces of equipment linked to a single section. And that's something you might want to avoid. You want to make sure you collect them together. The reason we do this for failure reporting could be a good reason. So if I'm looking at failures down in, say, my component level or my subunit level, and I want to roll those up for maybe the plant manager is interested in, so what's happening from a plant to plant, or somebody even higher than that, a CFO saying, hey, for the business categories, how does roll up? You want to make sure that you've got them captured accurately so you can begin to build those reports that way. We also will use it when we do criticality analysis as well, so we'll want to know if we've got tens of thousands or hundreds of thousands of components, we may want to drill up into the hierarchy somewhat to be able to take a first pass at criticality there so that we can understand what's happening at a higher level with maybe a more manageable number of components or assets. Rona mentioned I worked for Walt Disney World for a while, so I thought I'd give you an example of at least one that I put together anyway. So this would be the way I might do something where I was working before. So we had entertainment. I drill that down into parks and resorts. There's many different areas that make up Walt Disney World as an entertainment industry. One of those parks would be the Magic Kingdom. We have a attraction in there called Space Mountain that's part of the Magic Kingdom. So all my attractions would live at that number 4 level. Space Mountain's made up of, braking systems, there's lift systems, there's different systems, so I'd have a number of systems that maybe lived under that, and so that's all in my use and location area. And then part of the brake system is either potentially air applied brakes, so I've got an air supply that I need. I've got a compressor that runs it, motors and bearings as well. Other thing to point out, and ISO 14224 makes a good note of this as well, if you go and reference the document. That level 9 is typically not in your CMMS or loaded into the hierarchy. That's typically what we would think of as those bill of material components. So those are the things that would live. I may not need to, I'd probably start with level 8, which we call typically our maintainable components. And then we build out the BOM in that level 9. But like I said, the level numbers aren't important. The important part is that you have nice gradations between your levels, and that you don't flare out at some point, and it's not a completely flat hierarchy. So once you got it into hierarchy, we'll go into the analyze phase now, the one that I'm calling how. And I got another poll question for you. So what I'm interested in now is your concept of risk and how you're using risk today in your company. So hopefully some of these terms ring a bell. If there's others, and certainly got others. So are you using it really in a PSM or a process safety management? So when I know where my risks are, but I'm only really maybe applying it in a safety concept. Same thing with maybe a hazard analysis. We're doing some of those. You're doing cost-benefit analysis. That's another way we can use risk. Or are you using failure modes and effects analysis, which is we'll go into a little bit later, another way of using risk. Or if I didn't list it here, maybe you click other, and we'll see how this turns out. So Ronan, I'll turn it back to you.
Okay. So we're trying to determine how risk enters into your decision-making process at your company. So please just answer, is it process safety, hazard analysis, cost-benefit, failure mode, or something else. All right, so we've got about, people have to think a little more about this one. We've got about half the votes in, so I'll leave it open here another 15 seconds or so. And also, many people have been asking about getting copies of the presentation, so just want to reiterate that we're recording it. We'll share a link to the recording, and also Bill's team has been kind enough to share a PDF if you request one at the end of the session. Okay, I think we've got the votes in, so let's go ahead and share results. So Bill, about 8% say they use risk in process safety management, 10% say in hazard analysis, 31% look at it from a cost-benefit analysis, 39% FME, failure mode and effect analysis, and 12% use some other means of having the risk enter into the decision-making process.
Great, very good.
Right.
I'm glad to see people using risk, certainly in those different scenarios. So I'm going to go into two ways right now. The first of which is what we would call a criticality analysis. So those that aren't familiar with this, I'll go through just a real quick example of how we would start typically a criticality analysis. So what we're really trying to do is we're trying to take this list of assets, and let's say these are that equipment that lived on my maintainable component level of my hierarchy, and this is why we do hierarchy before we do our criticality analysis. So I've got my list of maintainable components, but I need to really decide how I'm going to attack the mitigation of the risk associated with this. So I'm setting, imagine we're setting up our proactive culture. I'm not going to wait for these components to fail anymore, but I need to know how I address each one of these. And the first step we think to doing that is being able to understand the level of criticality associated with each one of these assets and being able to put it into an order so that we can address them with some techniques we'll use later on. I'm going to show 11 categories of what we would call factors of criticality in here, and so some of the examples are business and safety impact. So environmental as well, so whether the components of single point failure, spares, lead, how reliable it is, and we go all the way down to decommissioning. These may or may not make sense to you. If you've done criticality in your plant already, you may or may not have used something like this before. Like I said, these are just some examples of ones that we would use. And the way we come out with our final criticality for each one of these assets is we ask ourselves, what's the impact to each one of these categories, each one of these factors, in the chance that one of these assets were to fail. So you can see that, let's just take that business impact column to begin with there. So we would have to define for ourselves, and we usually use a scale of 1 to 10. We need to define ourselves what's the maximum business impact we could sustain. And in this case, asset 2 is the asset that causes us the most risk from a business impact standpoint. So it's going to either cause the greatest amount of loss to our production, and that might be a 10, and we've got to sort of calibrate that to whatever our business means. And then if one of these was a 1, perhaps there was no impact to business. We can run with that. It's a redundant piece of equipment, or it's something that we have a workaround built for. And so what we do is we score each one of these assets based on these categories. So you can see that these aren't very reliable components. So we've got 10, 10, 9s down there. But in the safety impact, asset 3 really has no impact to safety. It can fail, and we're not really worried about somebody getting hurt, but perhaps the other ones are. So once we're done going through these 11 categories, or however many categories you ended up with, the simple thing to do is we add up the value. We just go across all 11 categories, and we sum up the numbers, and we apply that to our criticality value for our asset. So in this example here, we would say that our asset number 2 was our most critical asset, because it scored highest amongst these categories, followed by asset 1, then asset 4, then asset 3. So you can imagine if you had thousands and thousands of these assets, as you go through and you score these, you would start to get this list re-ranked in order of this raw value, and then you would have a list of your assets from the most critical to the least critical asset. And so what do we do with that? Well, so we typically would break that list into 5 sections. And so we would say, all right, well, the top 5% of my scores, the top 5% of my assets, that's going to be one tier all the way down to there's the bottom 5%. And we would, let's take, for instance, that top 5%. That would be my top criticality. So in this case, it's an A. Maybe for you it's a 5, or it's opposite, it's a 1 to 5, however you want to do it. But what we'll do now is we'll apply different analysis, and as I fill out the rest of this table, you'll see the different analysis techniques and risk control strategies depending upon how critical that asset happened to be. So typically for our highest critical components, we're going to suggest doing an asset-specific FMEA. And a failure modes and effects analysis is what that FMEA means. And so that means going in and looking at it in its operating environment with the particular functions, so a very specific FMEA. And then the results of the FMEA, the things we'll be typically looking to do would be to come up with some predictive maintenance with that PDM, have some recommendations for preventive maintenance, some non-destructive evaluations, so maybe some inspections or some tests that we'll run, operator control strategy, and this is also where we may come up with redundancy. If we're not able to mitigate it through one of those, this is the case. These are those highly critical assets where we may need to look and say, hey, if a failure is unacceptable in any case, we need to have some redundancy in there. So we go through the list and we break it down. So the next category, we may only do an asset type. So if all the pumps that fell into this, we may do a pump FMEA and apply those findings across all the pumps. We might do motors as well. We get down to the middle category, and perhaps in this case we're just going to do a maintenance review of these. So we'll look at probably some failure history. If we've got some failure history, see what those typical failure modes are that are happening, and we'll make sure we put some predictive and some preventive maintenance steps in there to help mitigate those. Down near the bottom, we will probably just adopt perhaps some OEM recommendations, right? So what does the manual say to do? And we'll look at basic servicing and lubrication steps as well. And we could tolerate more failures down here because we know the risk associated with that failure. And from our criticality analysis, is not going to have the same impact as something up and higher in the list. And then basically down here at the very bottom, this is where we come back to where I was saying earlier about reactive and run to failure can be a perfectly acceptable maintenance strategy, is if I know that I don't have any risk or very, very little risk associated with that component failing. This is a case for we'll let these things run to failure. Because I've picked the right categories in my criticality analysis, I'm confident that I can overcome those risks associated with I'm not going to carry spare parts for this. Okay, well, hopefully I've done my homework and due diligence, and I know that I'm not going to suffer the losses like I would if I was not stocking spare parts for something high up on my list. So this is typically how we'd say we would then go through separating out those. And so you see they're large categories, right? So that's why when we do criticality analysis, we try not to get too tied up around whether something's a 7 or an 8, because you'll see they're generally going to fall into large buckets anyway. And we may also do these it may make more sense to you to do it into 3 tiers as well. So maybe you pick the top 10, the middle 80, and then the bottom 10. So it's completely up to you and your industry and your tolerance for this risk and how you choose to do that. This is typically where wheel life cycle would start from. So I talked a little bit about FMEAs, and I'll just go real quick for those who aren't familiar. I noticed in the poll quite a few said they were familiar with FMEAs, so I won't spend a whole lot of time here. But how we talk about mitigating these risks is we'll pick that asset, that system, or that process to analyze. So what was it that was up in that top tier, that criticality A? We'll ask ourselves, so what's the functions of that asset or system? How does it fail to meet those functions? And then what are the effects and those causes? Failure modes and effects is where failure mode and effects analysis comes from. We'll ask ourselves, what is those impacts? What really happens when that bearing loses its lubrication and it seizes? What's the impact to my system? And then what we'll want to do is we'll actually, through an FMEA, we evaluate the risk associated with that potential failure. And we do this typically through risk priority numbers. If you're familiar with an FMEA, you may have seen the term, the RPN number. So we'll look at the severity, how bad is this failure, the likelihood. So what's the probability that this failure is going to happen? It might be a high severity, but not very likely. And then the last category we use in an FMEA for determining the risk associated with this failure is going to be our detectability column. So how likely is it that I'm able to find that failure or see that failure before it actually happens? And so this isn't how likely it is, am I going to see the failure after there's a bunch of parts laying on the floor. What I mean is, how likely am I to find that before the failure actually happens and I'm able to do something about it and reverse the course. The fourth one then is I take all my RPN numbers and I rank those risks similar to what I did with the criticality analysis. So I now know where my riskiest failure modes and where my riskiest failures are, and then I assign corrective action around those. So I need to mitigate these risks. I've said these risks are unacceptable, and I need to put mitigating strategies around. And that's where that last column in that table I showed you before. So there's where I say, well, I need some predictive maintenance to lower or to change that detectability column, to lower that detectability. I'd never see this failure happening. It's unacceptable. I need to see this failure coming. So I'm going to put some predictive maintenance in. The likelihood of this bearing seizing from lack of lubrication is too high. I need to mitigate this. Well, put some preventive maintenance in. Go out there and lubricate it every once in a while. Okay, now I can start to lower that likelihood of this bearing running out of grease because I've gone out there and I've made some mitigating steps and put in some corrective action. And then, of course, it's all the planning in the world is nothing until I actually go out there and implement the corrective action and then reevaluate the risk. And so we suggest relooking at your FMEAs frequently, maybe every year, especially certainly on those top tier assets and components to make sure that you are mitigating the risk and that you don't need to reevaluate anything. All right, so there's our analysis phase. So the last thing we were left with there was a column of mitigating actions that I'm going to take: predictive maintenance, preventive maintenance, operator care, maybe tests and inspections as well. So now we need to move into this what phase. All right, so what am I going to do now? That's not quite enough to load into a CMMS. It's not quite enough to take action on yet. So I need to do something else about it. So now we're going to control and we're going to measure some things as well here. So I've got another poll, mainly around your maintenance tasks that you have today. So how do you feel your maintenance tasks add value? And I'm saying, you know, this is maybe a little bit if you're familiar with the term PM optimization, but do you feel your maintenance tasks add value to you? Yes, they're designed that way. We know exactly why the PMs that we're doing today are the PMs. We know why we're doing them. Yeah, but maybe it's coincidental, right? We're doing a bunch of things and we don't seem to have too many failures, but we're not quite sure the two are connected. And then no, we either aren't doing maintenance tasks or we certainly don't think they're adding any value. The worst thing is I'm out there doing a bunch of maintenance, yet I'm still fighting fires on a day-to-day basis. So I'll throw this back to Rona for the poll.
Okay. So again, one more poll question. Do you feel your maintenance tasks add value? So yes, by design, yes, kind of by default, I guess, or no, you don't feel they currently add value. We just do them. I guess to some degree, we're all in that boat at times. So please go ahead and give us your responses. All right, I've got about 80% in, so I'll give it a few more seconds. Okay, let's see how we fared. Bill, 2/3, 66% said yes by design, which is great. And 26% feel yes they do, but it's coincidental, and 8% feel no they do not.
That's great news. I'm happy to hear that people feel like they're adding value, and certainly that they were designed that way to add value. For those that maybe don't see the connection or don't feel their tasks add value, I'm going to step through a little bit of how we sort of classify some of these risk mitigation strategies, and begin to give you a little bit more detail. For those that aren't familiar, I won't go into a lot of detail on the PF curve, but the PF curve is a way of demonstrating the degradation of a piece of equipment's condition over time. And so what you see here on the right-hand side of the page is at time 0, right against the y-axis, a component is as good a condition as it's ever going to be. But as time progresses, we can see this line start to drop. So the condition is degrading. It's not as good as it was yesterday. And so over time, eventually, we'll run out of condition, quote unquote, and be down here at the 0 condition level. And the concept of the PF curve is basically saying that there are the old definition of failure was when the components were laying in a heap on the floor, and the pump wasn't turning anymore, the bearing was seized, and that would be really the point where the graph hits that x-axis. But the PF curve defines 2 new points along that curve. One is the P point near the top. That's our potential failure point, and that designates the point in time where the failure has begun to happen, but you're just beginning to be able to detect the failure has begun. The F point down at the bottom is the new definition of failure, and that F is for functional failure. And this new point designates the point of functional failure. So this is if your pump is designed to pump 1,000 gallons a minute plus or minus 100. Failure isn't when it's not pumping anymore. Failure is when it's dropped below 900 gallons a minute. Your function requires you to be able to pump at least 900 gallons a minute. I'm not able to do that anymore, so I've, in a sense, functionally failed. So that's the new definition of failure. This concept is not new. I didn't create it. It's been around for a while, so I imagine a lot of you have seen this already. So the difference really comes about when we talk about predictive failure. And so just real quick, I'll point out the 5 main technologies of predictive maintenance that we typically talk about. And we've got vibration, oil analysis, thermography, ultrasound, and motor circuit analysis. The 3 maybe that we don't always tend to think about really are that are still predictive maintenance techniques. They're maybe not using technologies or tools. They're visual indicators. So if you've got sight glasses in your oil reservoirs, right? I can maybe see cloudiness. I can see some things that are maybe in a grosser sense than a true oil analysis, but there's still some value in that. Noise, it's not quite ultrasound, right? It's come down into my hearing range. Heat, it's not thermography, but if it's far enough down on the curve. And so I've just highlighted a couple of parts of the curve here that kind of point out where these start to come into play on the PF curve. So the technologies are those, we're going to be able to find things much closer to the P point, right? So the reason we would want to find things closer to the P point is we need to take some action. The whole point of doing these tasks is that we can avoid the condition of this equipment ever getting to that functionally failed point. You know, certainly before it ever got to that bottom of the curve, but we need to start noticing these things, and being proactive is about noticing and anticipating failures. So once these components have passed this P point, when do I start picking up on the fact that the vibrations got higher than normal. The ultrasound, the dB level for the ultrasound reading is indicating something's amiss in the bearing. But I can find things much earlier, much higher, and give me more time for my planning and scheduling if I'm using some of those technologies. Not to be, dismissed. Your human senses are still at use there. The trade-off is I'm going to find them much farther down on the PF curve, but there's still a case for, if you haven't invested in the technologies yet, or you may not be doing that for quite a while, or it's just because of your industry not available in all those cases, we can still do predictive maintenance. And I like making this point that predictive maintenance is not just all about the technologies, it's also about being able to use those human senses. So consider those if you're not able to really use those technologies as well. So that's one sense. We'll come up and we'll try to mitigate most of those failures from our FMEAs through these predictive maintenance technologies. And this is really, we also would call this condition-based maintenance. So we're not doing things on necessarily a time base, but we're letting the equipment tell us what's going on, what's going wrong with it, and allowing it to dictate when we take action, when we take that proactive case. But once again, like I mentioned before, it's all about taking action. Don't let your technologies and don't let your senses tell you that something's going wrong and still suffer the failure for it. Take action as early as you can, make the plan and schedule the work, and make those changes and avoid getting down to that functional failure point. The next category are those preventive maintenance tasks. And preventive maintenance tasks, to me, to differentiate it from the predictive maintenance, are really those time-based maintenance things, those repairs, those restores. Certainly a case for these. We're finding more and more, if anyone's familiar with the Nolan and Heap RCM study that showed that 89% of the components that they surveyed demonstrated an end of life that ended randomly, where time-based maintenance and just a plain scheduled 6-month replacement, year replacement wouldn't make sense. That's why we try to drive a lot of this back to this predictive. There's still cases, plenty of cases out there for these time-based maintenance tasks. Certainly in lubrication and in general servicing, topping off fluids, wiping, doing things like that as well. Those type tasks come out of those FMEAs as well. There's a lot certainly of discussion nowadays around operator care, TPM, trying to find the right types of tasks that we can partner with our operations folks to try to, they're the ones that are living with the equipment on the day-to-day basis. They're the ones that may or may not be able to detect those changes, those subtle changes in the equipment. Cleaning, certainly, making sure that you can't find the sources of the dirt if there's already a pile of dirt laying on the equipment. Minor lubrication, certainly, they're out there at the equipment. There's lots of things that our operations folks can do. Checking for early issues, so if we're using some of our human senses, who's the one that's standing by the machine most of the day and can easily find these things higher and higher up on the PF curve. Certainly those operations folks, train them in those things that they should be looking out for are real important. So those are the types of risk control strategies we see. I just wanted to throw a couple of typical metrics and KPIs, and these are things that you may or probably are using today, you may not be using. And the reason we always throw in metrics and KPIs here is this is in the sense of continuous improvement. If we've done all the work and we've gone through the classifying and the analyzing and the controlling of these risk mitigations, and we want to make sure that what we've done is having the results that we intended. So if we've baselined our OEE, we know what the mean time between failure of the equipment is, we know how long it's taking us to repair it, and we have all these metrics. We need to continue to measure those and make sure that we're moving those metrics in a positive direction. We're having the results that we really intended to have. So having good metrics out there before and after this is really important so that I can know I'm not getting the results I want. Maybe I need to go back and redo my FMEA. Hey, I'm seeing a piece of equipment that is a repeat effect. I'm getting a lot of repeat failures, so I need to go back and maybe redo my criticality analysis. It didn't show up in the right area. So I just have some quick final thoughts. When we typically do these, we would generally consider a pilot area, and this is something I would suggest to you as well. If you're out there and you want to do some criticality analysis, take a bite-sized chunk. Go out there and look at a particular area. Perhaps it's a pet area, the plant manager, or it happens to be an area that we can presume has a lot of critical components in there. Go out there and just look at that area first, and then go through. We talked about the where, how, and the what. That continuous loop, right? We want to go through, do those things, and maybe check ourselves back again. And then maintain momentum. Very important. This is tends to be a large-scale process. There's a tendency to get bogged down in some of the details, like I mentioned before, the criticality analysis. The 7 and the 8 in the 10th column there, it's probably not going to make any difference when it comes to the next stage of classifying these. So don't get bogged down in the minutia. Maintain momentum. Get people excited about this. Try to show that value and what you're going to get from this, and continue to move forward. Last poll before I wrap it up. So just kind of curious, if you're listening to this webinar, I imagine you have some interest in transitioning from your run to failure, or maybe tweak your current. If you feel like you're in a proactive case, maybe you're looking to tweak it, or you don't think you're getting all the value from being proactive as you can. If you are looking to move from a reactive or a slightly or maybe somewhat proactive, and you're looking to make some of these changes and something ring a bell with you, let me know. Just real quick, what are you thinking about? You're acting in the next few months. You don't have any plans right now, or perhaps you're proactive enough. So I'll turn it back over to Ronan just to get a take on where you guys are. Are you there, Rona?
Sorry about that, guys.
That's okay.
I do mute myself, but the polls are open. The people are responding, and let us know now that you've digested what Bill has said, what you think your next steps are. All right, and then we're going to wrap things up and entertain a couple of questions. Okay, so let me share that with you, Bill. It looks like 39% said yes. They do have plans to move in the next 6 months. 31% yes within a year. 11% said yes, but over a year from now. 9% no plans, and then 11% said no, we feel we're proactive enough, just checking in.
Great.
All right.
Well, that's good. I'm hopefully maybe something I said today resonated with you, and maybe helps sort of blaze that path, and will help you move forward. Like Rona said, that kind of brings me to the end of what I wanted to talk about today. We look like we still have a few more minutes here, so Rona, if you'd like to maybe ask, hopefully maybe 1 or 2 questions, I'd be happy to see what I can do.
Sure. One of the things that a listener asked us about, Bill, is you mentioned about the time-based, that sometimes you might be, over PMing, but I think we have many listeners on the line where we also support usage-based. And do you find the same kind of results, that 89%, when you do base it on run hours or equipment usage? Do you see improvements over purely a time-based inspection?
I mean, I would say definitely yes. Sorry about that, throwing that 89% out there. That's from a study at the beginning of RCM. That's not a number that I necessarily know, but I can answer your question by saying certainly I believe that there are just big advantages for moving from a purely time-based to a meter-based, mileage-based of case. We're getting closer and closer to that condition-based where I think we really ought to be trying to head, but in lieu of that, certainly moving from a pure time-based, regardless of how I've been using or scheduling that equipment, back to a usage base is a very good thing for you to be doing.
Excellent. And you also mentioned, there's different types of, you touched on FMEA, RCM, and fracas, and the different types of analyses. And Can you just shed some, a little insight on which one you kind of apply when, or, just kind of educate a very high-level overview on those different types of analyses?
Yeah, I'm not, I don't have a lot of background or experience in RCM. What I do know and how we approach, we being Lifecycle, how we approach FMEA is very RCM-esque. We don't typically do what would be a typical bottom-up FMEA. I'm going to take a piece of equipment and I'm going to dog down every single failure mode and make sure I mitigate every single one of those failure modes. Our FMEAs are more of a top-down approach, which my understanding, like I said, I'm not an RCM expert by any means. What they mirror more of an RCM approach where we ask ourselves, all right, so here's this critical asset. What are the functions of it? How does it functionally fail? So in my limited experience, like I said, with RCM, I see the two of them hand in hand, and that's generally where we do most of our analysis work is through the FMEAs. I think there's a lot of value in that. You mentioned Fracus. I've got some experience with Fracus using in some previous jobs and some previous lives that I had. I think of even Fracus as really a real-world FMEA, where I'm taking FMEA and I'm maybe presuming some potential failure modes to try to comb out some of those risks. Hey, I've got some issues that may be happening. If I take the FMEA form in my case and I load it with all my known failure modes, well, I call that Fracus. That's a failure report and analysis and corrective action system. I don't have to sit down and presume what failure modes I might have. I've got a list of them out of my failure history, so I can load up that same FMEA form with my real-world failures and approach it in that same sense. So I think they all go hand in hand. But maybe just to answer your question, the FMEA form using that risk priority numbers is definitely where we go to first.
Excellent. Well, I'm afraid we're at the top of the hour, and we've just really had a very large group here today, a lot of questions, but we are out of time. So Bill has been kind enough to share his contact information. We don't want the dialogue to end here. So thanks so much, Bill, for putting this together and really provoking a lot of thought here. What we'll do as follow-up is we're going to send everyone who's attended today a link to the recording with today's session. We'll also, any of you who want to get a copy of the presentation, just when we end the webinar, click that box that says send me a copy, and Bill will be happy to follow up. Or we encourage you to, if you have further questions, reach out to Bill directly, because he and his team have a world of experience.
Be happy to answer any questions by all means.
So thank you, Bill, for putting this together, and thanks to all our listeners today. We will have a short survey. Thank you to Bill. Thank you to Lifecycle Engineering for sharing their just tremendous expertise. We put on these on a monthly basis. Again, this is open to all, not just eMate users, but any listeners that, really want to improve their best practices. So please let us know. We want to make sure we're presenting topics that will really help you do your job better. So please respond to the survey. Thanks again for Bill, and thanks for all our listeners. Sorry we ran out of time, but we hope we'll see you all the next time. Take care and have a great day.